Okay, on to number 21. In problem 21, we're doing tan of 13 pi. So you might want to consider where you're at if you rotated to 13 pi. If you go to 12 pi, that would be 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, all multiples of 2. Get you right back here to 0 degrees. So if you were at 12 pi, you'd be right back here. And then you want to go an extra pi. So 13 pi is the same thing as being at 1 pi, where the coordinates are, and again, you're assuming you're on a unit circle, where the radius is 1. Okay, so if this radius is 1 right here, that actually represents your x-coordinate. And since you're out this direction, your x-coordinate's -1, your y-coordinate is 0. Tan is defined as y over x. So the y is 0, your x is -1, your tan value is 0. Again, this is what's called a quadrantal angle, where you're not in between two axes, but you're right on one of the axes. 22, secant of 210. Now we start to get into having to understand reference angles of 30 degrees, 45 degrees, or 60 degrees. Those are all special right triangles for which you are expected to have the values on the triangle memorized. This has to do with, which you'll see when I rotate, what the reference angle is, which is going to dictate how the triangle looks. So if you rotate to 210, that means you've gone to 180, and then you've gone an extra 30 degrees to get you to 210. Okay, so you're rotating, rotating, rotating. You keep going an extra 30, and this 30 degrees is what we call the reference angle. Okay, travel up to the x-axis so that you can complete your drawing of a right triangle. And the values associated with a 30-degree triangle are, across from the 30 is the short leg. You can actually let it be any value you want, but the easiest thing would be to let it be 1. How you get the rest of these values are by knowing the formulas for a 30, 60, 90 right triangle. And that is whatever the short leg is, that's this guy right here, which is always across from the 30. The hypotenuse is always double that. That would come from you memorizing the formulas. And then across from the 60-degree angle, which is this leg right here, is whatever the short leg is, which is 1 times square root of 3. Now, because of the quadrant that you're in, this x value, see this leg right here represents the x value, and in this particular quadrant all x values are negative, and in this particular quadrant all y values. This leg right here that goes up and down represents the y value, and it is negative. Okay, now that you have the correct values and the signs that are in quadrant 3, now we're going to do secant. Secant's associated with cosine. It's the reciprocal of cosine. So cosine is x over r. This is r over x. Okay, the r is the hypotenuse, and the x value is the negative square root of 3. When giving your final answer here, you can float the negative to the top. Don't forget to rationalize if you end up with a radical in the bottom, as we have here. So multiply this by square root of 3 on the bottom as well as the top. And you end up with 3 on the bottom, -2 square roots of 3 on the top. And that's your final answer there. 23. Okay, 23, you are being asked to rotate to sine of 855. So what I would do is figure out how many full rotations you can get in but not go over 855. In other words, every rotation, complete full revolution around the circle is 360, and I think you can get a couple of those in. 360 times 2 is 720. 855 minus 720 leaves you with 135. So if you were at 720, you'd be 1 full revolution, 2 full revolutions. You'd already be at 720 degrees. It was right here at the 0 degree mark. And in order to get to 855, what I did is I subtracted this from 855 to figure out that I need to go an additional 135 degrees. So that would not be quite all the way to the 180 mark. Okay, this would be an extra 135 degrees. So 720 plus 135 is this 855. Now, I'm going to make a right triangle out of where we're stopping. This represents the hypotenuse. And if this is the 180 mark, you've gone 135 of that. That means 45 degrees is left as your reference angle. So you're in a 45, 45 right triangle. Okay, the formulas associated with that kind of right triangle is that the legs are equal, and we can allow them to both be 1. In this quadrant, the x's, which is horizontal leg represent the x's, is negative, and the y coordinates, which is this vertical leg, are positive. So I'll leave that one as a positive. And then the formulas for this kind of right triangle say that if you take a leg and multiply by square root of 2, you get the hypotenuse. It's a formula for a 45-45 right triangle. It's how you get the hypotenuse. Hypotenuse is always positive. That's why I don't have a negative there. And then when we go to calculate the sine, now that we have all our numbers, we can calculate the sine right off of this right triangle that we've created at 855, because you've gone 720, an extra 135. So where this hypotenuse is represents you landing at 855. But because you're at 855, you have a 45 degree reference angle. So now you're using the numbers on the right triangle and the definition of sine. So this represents the y value. The square root of 2 represents the hypotenuse, and you're going to rationalize this answer. So multiply by square root of 2, square root of 2. That gives you square root of 2 over regular 2. Okay, that's 23. 24. You are calculating the secant of 11 pi over 4. So these last few problems are about, do you know how to rotate around the circle and move any additional distance to get to the designated value that they've given you here. So 11/4. Let's see, how many full revolutions would that be? If you're talking force, this would be 4 force. In other words, 1 pi. This would be 8 force, same thing as 2 pi. And that's if you're rotating like this. Okay, once you rotate full revolution, you're at 8 pi. Now we want to go to 11 force. We've already gone 8 force by going to 2 pi. We have to go an additional 3, 9, 10, 11 force. So here is 1/4, 2 force, 3 force. Okay, you're going to go right there. So 1/4, 2 force, 3 force. You're actually at 11 force. So 1/4, 2 force, 3 force, 4 force to get right here. So this little angle is that extra 1/4. Drop down to the x-axis. Try to realize that pi divided by 4 is actually 45 degrees. So you're in the same kind of situation as you were right up here. You're going to have -1 for this leg, +1 for this leg, square root of 2. for the hypotenuse. Okay, secant is associated with cosine. Cosine's x over r. So this is r over x using the values on the triangle. So -1 you get over, or sorry, excuse me, that's supposed to be the r value. So square root of 2 over the x value, which is -1. So negative square root of 2. And that's 24. Continuing on to number 25. Okay, in problem number 25, it says cotan of theta is square root of 7 over 3. And you got to think about how this is defined so you know where to put these numbers. Cotan is defined as x over y, the reciprocal of tangent. And you've been asked to find the tangent. Now, I would tell you to draw this, but since tan is directly related to this, you really don't have any work to do. This is a problem where you actually have no work to do. This is just the reciprocal of this. So you really don't even have to go into the drawing where you would have to know which one's x and y. You can just simply flip that over. And that just leaves you with a tiny bit of, I don't know if you want to call this work, but you're rationalizing it. So want to show that. You're floating the radical to the top, ending up with 7 on the bottom, and that's your final answer. Okay, 26. 26, it says cosine of theta is equal to 2/5 with theta in quadrant 4. Okay, so cosine is defined as x over r. So if you wanted to draw a picture in the designated quadrant, you'd be right in here. This is quadrant 4. This hypotenuse just represents the rotating arm. You have values already here. You have a 5 for your hypotenuse, which is always the r value. And the x value is 2. And if you need this because of what they're asking you to calculate, then you can get it by Pythagorean theorem. So let's see what the question is. The question is that you should be trying to find sine of theta. The theta is right here. Since the definition for sine of theta is y over r, yes, you do need to do Pythagorean theorem. So this will represent your y value, the leg that goes up and down like a y-axis. So it's always hypotenuse squared, this is the hypotenuse, is equal to leg squared plus the other leg squared. This is 4, this is 25, this is y squared. Okay, subtract 4 from both sides and you get 21 is equal to y squared. And then to get y, it's square root of 21. Okay, so your sine value ends up being the y value you got, square root of 21, over the r value, which we were given as 5. That's your final answer for 26. Okay, 27, find the indicated value. You're given a right triangle that's already been drawn for you. This was 75, this is 40, so this is simply about Pythagorean theorem, and then you finding secant and cosecant. So the first thing we'll do is find this hypotenuse. So it's hypotenuse squared is equal to one leg squared plus the other leg squared. Okay, this comes out to be 7,225. And if you're going to get R, you're going to have to take the square root of this as well as this. And that would be, square root of that is 85. Okay, so now you have this, and the questions that you were supposed to answer here were secant, and pay attention to the angle that they're putting right next to the trig function. When they say find the secant of angle A, that means you need to be standing on angle A. Okay, so let's put those letters on here. This is angle A, this is angle B, and this is angle C. Now, since you are not inside of a circle, what you need to use instead of x over r, y over r, and those kind of definitions is the SOHCAHTOA definitions, because they will apply no matter what angle you're standing on. Whereas when you're using the x over r, y over r, you're in a unit circle. So this has to do with cosine. Cosine, according to SOHCAHTOA, is adjacent over hypotenuse. But this is the reciprocal of that, so it's going to be, instead of adjacent over hypotenuse, hypotenuse over adjacent. So hypotenuse is 85. And the things that matter where you're standing is when you have adjacent or opposite as part of the definition of the value that you're trying to find. As we do here, we have the word adjacent, so it matters where they've asked you to stand, which they've asked you to stand on angle A. So standing right here, this is the adjacent, the side that runs into the angle, and that is called the opposite. Whereas if you were standing on B, they would be the reverse of that. So in the case where you're in a triangle that's not in the circle, you're going to want to use the SOHCAHTOA. So standing on angle A, adjacent would be the 40. And then you can reduce that in your calculator or by hand. And you get 17 over 8. Okay, 28. Getting close now. They give you a diagram and a point in quadrant 3. I'm not going to draw the whole circle, but the point that they've given you right out here. And of course, you're not going to be redrawing this. It's just that I don't want to draw on the actual test that I have. So they give you an x coordinate and a y coordinate, as you've been given in several other problems that we've already done in this practice exam. All they've asked you to do here is they've asked you to find the sine of theta. And again, as soon as you're asked something, you might want to write the definition of how you get it. Okay, now you are in a unit circle where the radius is 1. So sine is y over r. You've also been asked to find in this problem cosine. And the reason that there is no work for this problem is because just in the things that they've given you, they mention in the problem that you're in a unit circle. All unit circles have a radius of 1. And you already have the x and the y. So when you go to do the sine, it's just the y value over 1. So without drawing it or doing anything, just this definition and the fact that you understand that unit circle means radius of 1, so you actually have everything you need. So your final answer for sine, -3/8. Cosine, you have everything you need for that. It's just the x coordinate they gave you divided by the r value. And I don't care if you show this step right here, because it's obvious that you could do that in your head. Okay, and there's the cosine. Okay, that gets us all the way up to 28.